Hi everyone, my name is Rafiqul Islam. Today I will show you Finpay microservice architecture where I will use different tech stacks. So let me explain the architecture. So there will be client Sogar UI which will be connected with Spring Cloud Gateway. I will implement here circuit breaker with fallback. Also there will be rate limiter with Redis. There is about 5 service including the API gateway. It will be 6. So auth service will handle the JWT token and it will verify the public key. Also there are some other API which will connect through gateway, account service, and also transaction service will use Kafka, and also it will be transactional and idempotency key. So there will not be no duplicate transaction to maintain these rules for this idempotency key. And also this transaction service will connect it with the Prometheus, which will be the system monitor, and also we can see the system performance with the Grafana UI. And this transaction service will connect with the notification service. We will use Fin client third-party API to connect to this service. And email, there will be only one channel right now. We can add it more. We can add more channel later. For now it will send the email, and every service will connect to PostgreSQL. And there is a fraud service which is the Kafka consumer. The transaction service will send the transaction in Kafka, and from Kafka fraud service will consume those events, and it will check if it is fraud according to our business logic. Then it will notify the Kafka, and also it will save in PostgreSQL, so transaction service can check the transaction, is it fraud or not. And we have the tracing for monitoring in log. So we have the micrometer, Zipkin. So through Zipkin micrometer will transfer the logs to Zipkin, and we can see the UI in Zipkin. We will see it in later. Let me explain the full architecture first. And there is also system log with Elasticsearch and Kibana. We can see the logs in Kibana. From Elasticsearch, Logstash will transfer the logs to Kibana. So here is the full architecture. So now I will show you what will be the final output of this project. So let me show you one by one. So right now I will go to the Sogar UI. So this is the Sogar UI. I have already created every API, so a minimum API. So I did not add a lot of things because it will be a long and lengthy. So to make it simple, so I just use all the technological stack to demonstrate all of these things. So you can see there is all the microservices docs are here available. We can authorize to call this service. So if you go to the auth docs, you will see there are some APIs. So I already have user. I already created the user. So here is my PostgreSQL. So I transfer some money from one account to another account. So there is the fraud check service too. So this is not fraudulent. So this is the API for transfer. Sorry, so this is the API for login. You will get the token from here, and using this token you go to the transaction service. Then you have the transaction controller. So here if you see, here is idempotency key. If the key is same, it will return the same transaction, so there is no possibility for duplicate transaction. So this will be the final response. After this is completed, so Kafka will transaction service will produce a message event to send to Kafka. So let me show you the message for transaction service. So this is our transaction service, I think. Where is the service name? Yeah, this is our transaction service. So you see the Kafka is producing event, and fraud service will consume this message. You see the received transaction from Kafka from ID amount 30 and user test@gmail.com. So this is the Kafka thing, and also you can see the all documentation from here. And let me show you the Prometheus. So Prometheus will if you go to Prometheus and go to the target health, so you see I have exposed 3 endpoints. So uh, this is the Kafka JMX exporter. So Kafka Kafka JMX will export this matrix, and we will use this matrix to Grafana to display the UI from Kafka messages or Kafka events. And also we expose two services. One is transaction service, which is running on 8083 port, and 8085 port is running for fraud service. So we will see this matrix in our Grafana. So let me show you the Grafana, which will be look like this. So this is our transaction service. We can change to fraud service, so it will update the system performance. You can monitor from it here. And here is also we have another dashboard, which is the Kafka exporter. So right now we don't have too much message, so I write some custom query to which I already included in the project. You can download it later. And what else? Let me check the architecture. So where is my architecture? Okay, maybe okay, Zipkin. So we can trace for logging and trace. So this is the let me show you one more. So tracing, so we have micrometer. From micrometer we have the Zipkin to see the tracing. So here is the tracing service. We can see the transaction service right now, and the tracing service is connected with the fraud service and transaction service. We can connect all of the service. For now I just connected these two, and we can see that if we see if we can change the service name, like service name. We can check the fraud service. If we run query, we can see the fraud logs and fraud tracing. And if we check the what transaction service, we can see the transaction tracing. You can expand it and you can show the details. So this will be the Zipkin for tracing. And finally we will see the Elasticsearch with Kibana. You will see I have included the transaction service log here. You can go to and check the details of transaction. And also the notification service will send the notification here. So you can see transaction is completed. So all of these things I will show you one by one. Okay, I forgot one more thing. I forgot to show you the rate limiter and also the circuit breaker function, where we can see the fallback if any service is down. Let me show you the rate limiter. So this is the rate limiter. So I have run this query to send the request to this API for transaction and the transaction ID, where bus capacity is 10. So if there is more than 10 requests in concurrently, so in 1 second, so it will show you the
11th request, there are too many requests, so you can see 4 to 9, too many requests. So other requests are, you can see the success response. So this is the rate limiter where we are using Redis. And also I want to show you the circuit breaker. So if I stop this service, so somehow if some service is stopped, so we can use the circuit breaker. So this is the transaction service. If I call any API from transaction service, you will see the transaction service is currently unavailable, please try again. So we implemented this custom message. So that's all. Now I will go to the full project to show you one by one, including the Docker setup and project one by one, because I am using the Docker environment. So let's go through it.